In this example, a person wants to know if his die is fair or not. Remember, to have a fair die means when you roll it, it should roll any face a sixth of the time in the long run. So to test the die, he rolls his die 60 times and he records the number of times that the die rolls the number 2. Turns out, in those 60 rolls, his die rolls a 2 5 times. So the given information already tells us the null and alternative hypothesis. Remember, he's trying to figure out if his die is fair or not. So the null hypothesis is that pi equals 1/6, which is approximately 0.167. So that would mean that in the long run, the die rolls the number 2 a sixth of the time, i.e., the die would be fair. The alternative hypothesis would be that pi is not 1/6. That would mean that the die rolls the number 2 in the long run at a rate different than a sixth of the time. And that would mean the die was not fair. Maybe it rolls the number 2 more often than it should. Maybe it rolls the number 2 less often than it should. But it would be something other than a sixth of the time. Okay, so that's given to us, the null and alternative hypothesis. So part A. It says use the applet to create a simulated distribution of 1,000 sample statistics, and we'll have the applet display our p-value. Okay, so I'm going to open up the Rossmann Chance applets, and I go to one proportion inference. Remember to go up to the top right and hide the coins. All right, in the probability of heads is always where we put the value of pi. It doesn't accept fractions, so I recommend that you go out a few decimal places, like 0.166667, for example. It's asking for our sample size n. Our sample size is 60. He rolled the die 60 times. It wanted 1,000 sample statistics, 1,000 dots. We are always going to check summary stats here. And I'm going to go ahead and select proportion of successes. And lastly, we want a p-value. So to find a p-value, we need to count the simulated sample statistics that are like our sample statistic or more extreme. Notice that we have a two-tailed test. I know that because the alternative hypothesis has a not equal to sign. So that means when we have our distribution of sample statistics, I'm going to be counting statistics on the right tail and the left tail when calculating the p-value. To do that, we go down here to the extreme as box, and we put our statistic in. Our statistic, if you go to number of successes and just put in that he got 5, and then you switch to proportionate successes, it actually will calculate that decimal for you. 5 out of 60 rolls is 0.0833, 8.33% of the time he rolled 2s. But if you want a two-tailed test, you need to come down here below that to options and select two-sided. So it's going to count on both the left tail and the right tail. And now I'll draw my samples and copy and paste the picture. Okay, so here's the picture, the distribution of sample statistics that I got from the applet. Again, notice to do a two-tailed test, because we had a not equal to symbol, you need to do a two-tailed test where it's counting statistics on both tails. That means you have to come down here and select the two-sided. This 0.0833 is because we had 5 out of 60 rolls was our p-hat. 60 is our sample size. We're getting 1,000 dots. All right, and so we see here that the p-value is given right here. It's also on this vertical line. Our p-value is 102 sample statistics like our observed statistic or more extreme out of 1,000 total sample statistics, which is 0.102 or 10.2%. 10.2% of the simulated sample statistics are like our observed sample statistic or more extreme. Now we want to interpret the meaning of that p-value in context. So recall, that means that we're going to use the definition of p-value, and then we're going to change the words in there to give the exact values in context. Okay, and the definition of p-value is as follows. If we assume the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is the p-value. Now we're just going to take out some of those words and replace them with the actual values and the contextual meaning. Okay, so it reads, if it is true that the die is fair, notice that is assuming the null hypothesis is true, because our null hypothesis is that the die is fair. So if it is true that the die is fair, then the probability of getting a sample statistic like p hat equals 8.3% or more extreme, so that's like a sample statistic like ours or more extreme, is 10.2%. That's the p-value. And lastly, we now make a conclusion about the hypotheses. Recall, if your p-value is smaller than the significance level, then we reject the null hypothesis and we have strong evidence in support of the alternative hypothesis. So our alpha is 0.05, our significance level is 0.05, but our p-value is bigger than our significance level because our p-value, remember, is equal to 0.102, which is bigger than 0.05. So we conclude that the null hypothesis is plausible. So we conclude that it's plausible that this die is fair. So rolling only 5 2s when rolling it 60 times is kind of a normal, usual, expected sort of result if the die is fair.